Hi everyone, welcome back to the channel. Today I'll be solving the Maths IGCSE paper code 05804 for March 16 question paper 42. I'll be solving question number 10 and part B2 was part where candidates lost marks because they did not know how to approach this question. But I will go over how exactly you should. So we'll start off with part A. We're given that 10 circles in the diagram each have have a radius of 1 centimeter, and the center of each circle is marked with a dot, so that will be useful for us. We have to calculate the height of the triangle PQR. That means we have to calculate this length over here. If I made this midpoint of QR as x, we would essentially have to calculate the value of px, or the length of px. So okay, so now we know that the radius of one of these circles is 1 centimeter. So similarly, this here would be 1 centimeter, this here would be 1 centimeter, as in the diameter would be 2 centimeters because 2 times the radius is the diameter. So this entire region here would be 2 centimeters, and this region here would be 1 centimeter. So the total length of PR is 6 centimeters. Okay, and okay, so whenever you approach a question involving triangles, the things you need to look out for is whether you can actually um, make this triangle into a right angle, so that you could use the trigonometric functions. There are certain rules like the sine rule and the cos rule that does not require right angles, but the Pythagoras theorem and using the regular cos, sine, and tan requires a right angle. So when you're given a triangle, see if you can divide into right angle triangles. Now over here, this entire triangle PQR, if I go down the center across the length PX, this is a right angle triangle, right? That means we can now use trigonometric functions, and we can also use um what's that, Pythagoras theorem on this. So I'll make use of Pythagoras theorem. Uh, Here we calculated this length, which would normally be denoted as C when applying the Pythagoras theorem. And this length over here would be 2 centimeters and then 1 centimeter. So in total, it's 3 centimeters, right? And this I'll denote as A. And according to the Pythagoras theorem, c square is equal to a square plus b square, and b is the height over here. So in this case, c square is 6 square is equal to 3 square plus b square, which is unknown to us. So b square would be 6 square minus 3 square, because if I take positive 3 square to that side, it becomes negative, so it will be subtraction, and b is going to be root of 6 square minus 3 square. Now on the calculator, that is 5 point, well, I'll round it to 2 because the actual value is coming up to 5.1962, like that. So it goes on like that, and to round it, I'm going to round it to the first decimal place to become 5.2, and that's the answer I'll write over here. But if you use a Casio FX82 calculator, the answer will actually be given to you as 3 root 3. So this is a simpler way and a more accurate way of getting proper answers, because if we round up our answers, our final answer might differ a bit. So I would recommend using this value. So anyway, now this dude uses the whiteboard pens that are a cylinder of radius 1 centimeter. Okay, so basically all of these circles present in the first diagram is the same as the one present in the second diagram. Now the diagram shows 10 pens stacked in a tray, which is the exact same as the first diagram, and the tray is 8 centimeters wide, which is also the same as the first diagram. So the point A is the highest point in the stack. We have to find the height of A above the base BC. So we need to find this entire height over here. So in our previous question, actually, we found the height over here. If you look at the previous one, we look at the current diagram, you can see that that's the height we found. So we know that this region over here, this additional height which we have to calculate, is 1 centimeter because it's a radius, and the same for down here. It's the same as the length from the midpoint or the center of the circle to the bottom of the circle, which again is 1 centimeter. So in total, it's actually 5.2 centimeters plus 2 more centimeters, which is 7.2 centimeters. That is the height up here. Or you can also use this form and write it as 2 plus 3 root 3. So moving on to the next part now, B2. The diagram shows a box that holds one pen. The box is a prism of length 12 centimeters. The cross section of the prism is an equilateral triangle. That means all sides of the triangle are the same. And the pen touches each of the 3 rectangular faces of the box. We have to calculate the volume of the box. So the volume of the box will be the area of the cross section into the length. So in this case, the area of the cross section is this triangle, and it's actually unknown to us. And the length over here is 12 centimeters. Okay, so this is just for some understanding purposes. I'll just erase this. So let's see. I'll draw this diagram a bit larger so that it can be more clear for everyone. Just give me a minute. Hope it turns out well. Okay, so just imagine that this is big enough circle that the circumference actually touches the uh, prism, this part over here, the cardboard faces, and this is the center of our circle. So there is one circle theorem rule you should be familiar with. It's that if a tangent touches the circumference of a circle, just imagine this is touching, sorry, it's a bit difficult drawing here. The and there was and the radius touch the tangent at the point where the tangent is touching the circumference. The angle formed between the radius and the tangent is going to be 90 degrees. This is a fixed rule that you should know. So in our diagram over here, we have the center, then we have the radius sticking out towards the point where the circumference of the circle touches the rectangular face. So the angle in this region, this shaded region, is going to be 90 degrees. The same applies over here where the circle is again touching the circumference of the circle is again touching the rectangular face. This will form 90 degrees between the radius and between the tangent. Same over here, 90 degrees. So now that we know, oh no, I have to redraw that. I had to redraw that. Let's just imagine that's the same as the previous one. But anyway, we now know that the angle over here is 90 degrees and the angle over here is also 90 degrees. Now, because this is an equilateral triangle, all of the angles will be the same and they will add up to 180. The reason why it adds up to 180 is because it's a triangle. So every triangle would have total angle of 180. And because it's equilateral, all of them will have the same angle. Now 180 divided by 3, which is the number of angles present in this huge triangle, is going to be 60 degrees. That means this angle over here is 60 degrees. Same goes for here, it's 60 degrees. The same goes for here, it's 60 degrees. And we know that the total angle of a circle is 360 degrees. Now this circle is divided into 3 portions, right? So 360 divided by 3 will give me 120. Yeah, 120 degrees. So we know that this angle over here is 120. We know that this angle over here is a right angle, this is a right angle, and this is a 60 degrees. So as I've mentioned in the previous question, whenever you're given a triangle, see if you can break it up to give you right angles. In this case over here, this shape, yes, it's a four-sided shape, but if you divide it down the center over here, you get a triangle. I'll just redraw the triangle. So it becomes like this, and this was our 90 degrees. So this point and this point over here is the same as this point and this point over here. Now that the shape is being divided by like separated into two, the angle over here, that 120, is going to also be divided by 2 to give us 60 degrees, and then this 60-degree angle at the bottom is now a 30-degree angle, right? So you know this is true because 60 plus 30 plus 90 is equal to 180, and that's a total angles within a triangle. So we also know that because this region here was the radius, it is 1 centimeter. So essentially we have this length, the angle that is opposite to it, and then we have this angle, and the length that is opposite to it is what we need to find. So the reason why we need to find this is because it was this portion of the triangle. And to find the cross section of this triangle, we have to make use of the formula half into base into height. So this region here would be the height, and this entire region down here would be the base. Right now, our x is going to be half of the base value. So using our sine rule, we can do x by sine 60 is equal to 1 by sine 30. So when you solve for x, you get sine 60 upon sine 30, and that is, let's see, the value you get is 1.73, but for accuracy on the calculator, it's displayed as root 3. And of course, I'll be using root 3. So because we know now that this length is root 3, that means this entire base of the triangle, or essentially the side length of the triangle, is 2 root 3, or 2 into root 3. It can be written like this. Instead of writing 2 into root 3, you can just write it as 2 root 3. So now that we have the base worked out, we have to find out what the height is. So because okay, so we know that this region here is 1 centimeter, but this region here would be another centimeter. We still have this height, which we haven't counted. Now, the best thing to do is that we can take this entire region. I'll just erase this a bit. We can take this region here, and we know that this length here is root 3. We know that this length will be 2 root 3, and we can find out what this will be using the Pythagoras theorem. So again, I'm just going to clear up the area a bit. It's true that this question is a bit lengthy, but it's actually quite fun to do when you understand how you should be approaching it. And that's also why I really enjoyed doing maths. Anyway, so our triangle over here, this hypotenuse, or C, from C squared is equal to A squared plus B squared. C squared over here is 2 root 3 square. That's equal to, what is the A over here? Root 3 square plus B square. Now B square is going to be 2 root 3 square minus root 3 square. So B is going to be on your calculator, it's going to end up as root 9. Now root 9 is 3. So we have that sorted out. Now we can calculate the area of our cross section finally. So coming back to our formula, which is over here, half into the base, which we found out to be 2 root 3, into the height, which we just calculated to be 3, we get the cross section area. Just clearing some space here. And that will be can be written as 3 root 3, or 5.2, and that into our length of our prism will give us a total volume, which is 36 root 3, or 62.4 centimeter cube. So that is the final answer. I know it's quite lengthy, but with some practice and knowing how exactly you should approach the question, you'll be able to do it. So that's it for this video. If you enjoyed, please leave a like. If you haven't subscribed yet, I'd appreciate it if you could consider doing so. Thanks for watching, and I'll see you in the next video. Bye bye.